right, well, welcome everybody to this session. So, as you know, focusing on BIM, Building Information Modeling. So we've got three construction. So a study of BIM uptake capacity in construction organisations, and I think that's in Nigeria, isn't it? That's the country you're focusing on. So second paper is looking at BIM and life cycle assessments and the integration of the two and how they're going to be effectively tracked and identified. And then the third session is looking at the prospects for integrated design process in implementing construction waste prevention. All right, so what we will do, we will run each presentation and then we'll stop and then we'll have live questions and answers between each of the presentations, okay? So we will we'll start off with Adeniyi, and I will run your presentation, and hopefully the audio will work okay. Here we go.
Alex, can I just mention?
Hello, everyone.
Oh.
Hello, everyone.
Is on. Okay.
Go on. Sorry, mention.
Please put all your questions on the chat. I'll be collecting all the questions, and at the end of each presentation, and be reading it out in case. Yeah.
All right. Good. Okay.
Onaopepo, and I am presenting a paper titled Rethinking Digital Construction, a study of BIM uptake capability in construction organizations. The paper is authored by Onaopepo and Niraj. My presentation will be in this order: introduction, summary of literature, research method, findings, discussion of findings, and conclusion. Indeed, there is the need to put building information to a more meaningful use, but there appears to be a gap in the actual deployment of BIM in practice, especially among small and medium-sized organizations and developing nations or low-income countries. Therefore, putting building information to a more meaningful use might be difficult. Hence, a clear understanding of BIM, building information and building information modeling, uptake capability status, is necessary. This circumstance warrants a reappraisal of organizations' strength on capabilities required for BIM uptake towards the target of global construction digitalization. The aim of this particular study is to assess the BIM Level 2 uptake capability of organizations and identify the underlying interactions between the capability criteria. Summary of literature. Among other information found in the literature, BIM capability was described as the ability needed to engage in a BIM process. This relates to the availability of BIM tools and protocols. One important thing as well is the description of stage 2 of BIM, which is the model-based collaboration stage, and that is the focus of this study. It is worth mentioning that the measures or the variables for assessing capability span different perspectives, which include process, policy, and technological perspectives. All are considered in this study, and this resulted in the 15 variables synthesized from the literature. Survey strategy was adopted, and the 15 variables obtained from literature synthesis were regarded as the ability needed to engage in the collaborative BIM stage, that is level 2. As mentioned, they included physical and non-physical attributes. Data collection was done in Lagos State, Nigeria, and the organizations that have at least fundamental BIM related experience were engaged in the study. Consulting and contracting organizations were involved, and questionnaire administration was in 2 stages. The first stage was to verify the suitability of the variables, and the second stage was the organization rating on BIM Level 2 uptake capability. 73 responses were obtained in each round, and data analysis was done using mean score and exploratory factor analysis. Kieser-Meyer-Holkine measure of sampling adequacy was used to establish the appropriateness of data for factor analysis, and a value of 0.66 was recorded. Maximum likelihood extraction and direct oblimin rotation were utilized. Findings concerning variable verification. None of the variables scored below 2.5, so none was eliminated. As a result, all the 15 variables were taken to the next stage of the research. Here is the outcome of the organization rating. None of the variables scored below 3.00. In fact, the least is 3.34 and the highest is 3.89. Using an eigenvalue of above 1.0 as a selection criterion, 4 factors were extracted, and factors explained 54.4% of the variance explained by the variables. Factor 1 is made of 3 components, and the whole explains 16.15%. The highest contributing factor is BIM usage level within the past 2 years, and the factor, that is factor 1, speaks of the past workforce disposition, current workforce ability, and the readiness to engage in service delivery now and henceforth. The second factor extracted was named preparedness for immediate service, and this factor is made up of 3 components, which is availability of which one of them is availability of well-trained staff on BIM. The factors talks about staff and legal capacity, which is an indicator of the organization's readiness to operate immediately at a BIM level 2 on a BIM level 2 platform. The third factor was named strength on basic facilities, and it explains 14.213% of the variance. The highest contributing component is no tendency to outsource BIM related activities. The factor 3, speaks of the availability and use of relevant facilities, and this is why there is no need to outsource. The fourth factor was named affinity for innovation, and it explains just 8.208% of the variance. The last factor extracted is made up of 2 components, and the highest contributing one is workflow practices and procedural changes necessary to adopt BIM are not problematic. This also speaks about the disposition of the organization, okay, and of course talks about the readiness of the organization to embrace new procedures. Extracted can be viewed as directions where capacity exists. But there is the question, since capacity exists, why is the spread of the deployment of BIM level 2 still very limited?
Sorry.
Venkatesh et al. Highlighted 4 main determinants of IT innovation success.
If I press
Extracted can be viewed as directions where capacity exists. But there is the question, since capacity exists, why is the spread of the deployment of BIM level 2 still very limited?
The last bit with
Venkatesh et al. Highlighted 4 main determinants of IT innovation success, and they are communication channels, attributes of innovation, attributes of adopters, and the social system. Based on the outcome of this study, it seems 3 of the success factors have been well addressed. Then there is a question. It seems there need to be more focus on the influence of social system, and this might help even the advocacy for putting to use building information in a more meaningful way. Thanks for your attention.
Okay, thanks very much. So questions, please. Please do put any comments in the chat you have, or put up your hand to speak.
So there's a question from Bill.
Okay.
He said, what are your plans with this research work? How will you use the finding now?
Right. Thank you very much for that. This was actually submitted as a working paper, so there is a plan to take it beyond here. But the basic thing is that this is just an attempt to establish the capability available in that area. And one key thing that came out of this is the fact that it seems the organizations are not, so poor when it comes to availability of capacity and capability. But there is a challenge with inter-organizational relationship, which I call a social system. So does that mean the organizations are not really ready to work with each other on electronic platforms? Or are there other challenges? So summarily, one of the key things I intend to do after now is to see how this work can be expanded, right? Probably bring in more variables and engage a larger audience, larger number of respondents. Then after that, how does social system, interconnectivity between organizations, how does it really affect the deployment of BIM level 2? So these are the 2 targets, the 2 plans I have, right, concerning this work.
Okay.
So the other question, sorry, he says, how will you use the findings now?
Yeah, the findings, this is the first phase of it. So it gives an idea of what is happening there. Okay. We can say capacity does not exist, but we know I can't point to a project that was completely delivered, on BIM platform. We know in some other parts of the world, 1 or 2 or a good number can actually be identified. But currently, I can't point to a singular project that was fully delivered, on a BIM platform. So the first phase is that, okay, a foundation has been laid, capacity exists, workforce, in terms of workforce, in terms of facility availability, and the affinity of these organizations for innovation. So first understanding exists. The next is how do we take it up from there? And one of them will be to move further to look at how social system actually affects the uptake of BIM level 2. So that's going to be one of the uses. If I can summarize, right, this is like a preliminary study, setting the ground, setting the scene, then the message has been received, then I'll move to the next level, which is the impact of social system specifically on the uptake of BIM level 2?
I do have a question. Alex, can I go? Sorry.
You go.
Yeah. Okay. Well, it's a question and observation, but then further question. So the observation is, why BIM level 2 when it's now known as ISO standard 19650? I'm guessing that's what it's called.
Yeah, thank you. There are definitely there have been a lot of changes in recent time, actually. Yeah, when we look at literature, almost a lot of them that are still existing are still referring to BIM level 2. So it's just an attempt to relate with what is currently available in the literature. Then beyond these further discussions, then new developments will have to be incorporated.
Yeah, but I think it will make your work current, maybe using, because obviously literature as far back as 2 or 3 years ago, yes, they will have BIM level 2. But further on to that, in terms of when you talk about maybe in the BIM level 2, because this is an area also in Nigeria I've looked at a lot, it's mainly technology they refer to when they talk about BIM. So how do you rationalize what we consider BIM level 2 in this country? Because it's not just about the technological aspect, it's more about the collaborative aspect, more about the integration that happens. So things like the EIR, the MDIP, is there any of that? Because when you use those big word BIM level 2, the truth is what happens in Africa is still basic. And when people talk about it, it's just technology.
Yeah. Well, if I get the question correctly, when we talk about BIM level 2, mind goes more into technology-related issues, right? But there was something I think I pointed out, which is the part of, inter-organizational relationship. And that is definitely where collaboration takes place, okay? If we talk about BIM level 2, oftentimes people think about, okay, you have the computer, you have the programs, the software applications, you have this and that. But how do we really have the necessary documents that are, meant to guide our interactions, okay, if we indeed want to collaborate? Are we really ready to share information the way we are supposed to share it? Do we actually understand, what we call the BIM implementation plan? Not just about, getting models drawn by architects, not just about quantity surveyors, using Costex and all others, okay, and structural engineers trying to use ARCAB and all the rest. How do we bring all this together? Okay, and I think for me, that's why the part of the issue with social system, which is basically interconnectivity between the entities in a system, seems very important to me. Maybe if the understanding of collaboration as it is, partnership as it is, interorganizational relationship as it is, maybe if it becomes stronger, then the issue of collaborative BIM as well can sink better in that territory. That's just my thought.
Okay.
Thanks very much, Adeniyi. Can I just make an observation? I know that I've done research in the area of BIM maturity. There's been a lot of work in terms of BIM maturity, applying a maturity assessment to organizations, to projects, to individuals. You've done a piece of work in terms of BIM capability.
Yeah.
Now, are they the same thing, or do they overlap, or how do they overlap?
Yeah. Basically, maturity talks about the phases of growth, okay? While capability talks about the ability or the resources needed to function in whichever, phase of growth you belong. A simple illustration I always love to use is, maybe college or high school and university. High school is a maturity level. University is another maturity level. But what is required at those phases, at the different levels, they differ. So it's basically capability talks about the requirements at the maturity level. Yeah.
So okay, just to follow on that, so obviously part of your work will be to develop a maturity level for you to match these capabilities.
Yeah, that can be considered. But the interesting thing is, Even in the literature, there are expected capabilities for each level, right? We talk about, the level 0, no BIM at all, the level 1, introductory object-based modeling, then the level 2, the model-based collaboration. So each of them have, kind of stated expectations, if I can put it that way. But of course, the territory we're talking about, maybe there will be some peculiarities. And I think there's always that opening for, developments on existing works. So a maturity model can actually also still be developed. Yeah.
Okay, thank you.
All right, excellent. Thanks very much indeed for your presentation. Thank you for answering questions.
Thank you very much.
We shall move on to the second presentation. So this is from Jiayi. Okay, here we go.
Hi everyone, I am Jiayi from the University of Hong Kong. I'm glad to have the chance here to give a presentation on our paper. The title is A BIM-LCA Integrated Method for Enhancing Efficiency of Embodied Carbon Estimation of Prefabricated High-rise Buildings. There are 5 parts in my presentation. First, I will introduce the research background and some previous studies. Then I will focus on the methodology part and provide results. Finally, I will give some conclusions. As we all know, climate change has been one of the most urgent environmental issues facing mankind. As the primary driver of climate change, carbon emissions have increased rapidly. Figure 1 shows the carbon footprint in Hong Kong. It indicates that electricity generation is the largest source of local carbon emissions, and about 90% of Hong Kong's electricity consumption is related to buildings, which means that buildings account for over 60% of carbon emissions. Hong Kong has taken actions to increase the generation and use of renewable energy to decarbonize operational energy as shown in Figure 2. Therefore, the share of embodied carbon increases, showing great potential for carbon reduction during the design stage. However, LCA of buildings is commonly conducted at the end of the design stage, which is often too late to guide the decision-making. Since building information modeling can provide design information, BIM-LCA integration is a powerful approach to perform LCA for buildings during the design process. However, a great deal of manual work is still needed, and the data interoperability between BIM models and LCA databases also remains a main challenge. The aim of this paper is to develop a BIM-LCA integrated method for enhancing efficiency of embodied carbon estimation of prefabricated high-rise buildings. Many researchers have developed BIM-LCA integrated methods in recent years. Here provide 2 classification schemes from other researchers. Scheme 1 proposes 2 types of approaches, and Scheme 2 provides 5 strategies. However, these 2 schemes do not have a clear basis and cannot provide a comprehensive classification system. In our paper, we divided BIM-LCA integrated methods into 4 categories, taking the calculation platforms as a critical factor. Type 1 is to use Excel as a calculation tool, which is the most widely adopted method due to its simplicity and quick feedback. Type 2 adopts tools like Access, Circle, and Python instead of Excel to streamline the calculation process. Type 3 performs a simplified LCA in the native BIM environment with inserted LCA data. And Type 4 is superior in the professionalism and reliability by importing the BIM data into dedicated LCA software. Despite numerous advantages, 2 challenges have been discovered and emphasized. First challenge is the burdensome and cumbersome process of selecting proper LCA data from diverse data sources. And the second challenge is the data interoperability between BIM and LCA tools. These limitations impair the efficiency of BIM-LCA methods. This paper adopts the Type 4 by using CIMAPRO as the calculation platform. CIMAPRO was selected as it is one of the leading software tools used for LCA and has been used in more than 80 countries. It has integrated with several LCA databases, thus providing sufficient carbon emission factors. The adoption of SIMAPRO can eliminate the manual work of selecting and collecting LCA data and better facilitate sensitivity analysis. To address the data interoperability between BIM and SIMAPRO, an automatic data mapping and transferring approach based on the IFC schema was developed. Figure 3 shows the methodology framework for the development of the proposed method. This study was implemented through 4 steps. First, the establishment of BIM model. Second, data transfer between BIM and LCA. Third, development of BIM-aided LCA model. And finally, model efficiency validation. The whole process was based on a 5-level analytical framework for estimating prefabricated buildings' lifecycle carbon emissions, namely the material, component, assembly, flat, and building. In step 1, the BIM model was established based on the 5-level framework. Here takes Revit as the example. The components and assemblies need to be created as new family types, and the compositions of a flat need to be assigned to a whole group to identify the flat. The BIM model will be exported in IFC format after finishing. In step 2, an IFC-enabled data transfer tool was developed to extract data from the BIM model and to convert data into LCA data structure. Figure 5 demonstrates the data flow of the method. By inputting the IFC file exported from BIM software, element quantities and hierarchical relationships based on the 5-level framework will be extracted and then integrated into SIMAPRO templates, which will be outputted as CSV files for LCA input. With the output, step 3 is to develop the BIM-aided LCA model in SIMAPRO. The 5-level elements are defined as products in the LCA model. Figure 6 illustrates the overall framework of the BIM-aided LCA modeling process. Data acquisition is completed in step 1 and 2. By importing the CSV files into SIMAPRO, the LCA model can be automatically established. And if the design BIM has been modified, data updating in the LCA model can be also automatically achieved by re-importing the updated CSV files and overriding the original data. To validate the model efficiency, a typical floor of a 30-story prefabricated residential building in Hong Kong was selected for case study. This table provides the 5-level products defined in the LCA model. A comparative analysis was conducted between the BIM-aided method and traditional method using 2 indicators, modeling step and modeling time. In the traditional method, the modeling steps depend on product types, which means manual creation of one product should be counted as one modeling step. However, in the proposed BIM-aided method, modeling steps are independent of case specification owing to the data import function provided by SIMAPRO. Thus, only one step of importing data is needed. In this case, a total number of 86 modeling steps were omitted. If applying the method to the whole case building, more steps could be reduced. The total modeling time in traditional LCA was estimated by multiplying the mean value by the number of product types. When importing the files in the BIM-aided method, it took around 30 seconds for data input at each level. The reader chart indicates a significant enhancement of time efficiency, above 97% in terms of component, assembly, flat, and building, and an 80% of time saving was achieved considering the whole process. The novelty of this paper can be concluded in 3 aspects: theory, data, and method. In theory, a 5-level analytical framework of prefabricated buildings was applied in the proposed method, while the prefabrication system was rarely considered in previous methods. The framework can facilitate standardization of embodied carbon results. In data, this paper adopted 2 new indicators, modeling step and modeling time, which were rarely measured in previous studies because efficiency was not their focus. This paper aims to enhance the efficiency of carbon estimation so that the 2 indicators were adopted to identify the extent to which carbon estimation efficiency has been improved. In method, this paper proposes a new method for estimating embodied carbon emissions by integrating BIM models and SIMAPRO based on the general IFC standard, and also proposes an idea of adapting BIM data to LCA data structure to address the data interoperability. The proposed method is advantageous over previous BIM-LCA integrated methods in several aspects. First, it reduces huge human efforts in finding appropriate impact factors from various data sources. Second, it can conduct more comprehensive and accurate LCA owing to the professionalism of SIMAPRO. Third, it achieves automatic data transfer from BIM models to LCA software. And fourth, the development of a general IFC-enabled data transfer tool eliminates the limitation of specific BIM software. Overall, this paper contributes to smart embodied carbon estimation and facilitates the quick feedback of embodied carbon emissions during the design phase to support building design efficiency. That's all of my presentation. Thank you for listening.
Thank you very much. There's a lot of detail in there. I'm sure people will have some questions stemming from what we've heard. Does anybody have a question, please? Can I just start then by just asking you that question? Obviously, tremendous improvement in efficiency. 87% or whatever it is in terms of time saving. It's just that initial section materials, isn't it? That there is no saving at the moment. Is that because everything associated with materials in LCA has to be manually typed into your software to begin with? Is that the reason why?
Yes, because in the BIM software, the materials cannot be identified with the compositions. So these materials should be defined in the LCA software in advance. And then when we build the BIM model in the BIM software, we should use the same name for materials as in the LCA software.
I see. And is there any way around that in the future to try and get material identification up front?
I think it may. Yeah, maybe we can establish a common material database for both the BIM software and LCA software, and we can establish a common name convention so that it may be easier for the automatic data mapping at the material level.
Yeah. So that's a project for the future then, isn't it?
Yeah.
Okay.
I think it's a big work, maybe.
Big project, yes.
Yeah.
Thank you.
Can I just add this? So you talk about the method. What's different with SIMPRO? Because initially you started about the issues are lack of interoperability. Are you saying that SIMPRO doesn't have that issue with maybe with other tools like the Autodesk or?
No, SIMPRO does have the data interoperability. The data interoperability between BIM and LCA that exists no matter what software we use, but SIMPRO provide a function that we can input the CSV files into the SIMPRO, and it can read the CSV files and can automatically establish the LCA model. So if we can extract the required information from the BIM model and then restructure this data into the SIMPRO data structure, so it can be easier for SIMPRO to read the BIM data. So actually, the data interoperability was addressed by a data transfer tool, and the tool was developed by our team. Yeah.
Okay, so what you're saying is SimPro is not you didn't your research team didn't write SimPro. It's you've added something to it. Is that what it makes it innovative?
Yes, we developed a data transfer tool. The tool can extract the required information from the BIM model,
okay.
and then we can restructure this data into a template, and then the template was also developed by our team. The data structure in the template can be read by the SimPro.
Okay. There's a question from Bill. It says, "Is this research tool limited to making estimation for prefabricated building elements?"
Well, our scope was limited to the prefabricated building system in Hong Kong because we adopted the 5-level system, the 5-level prefabrication system. However, I think the whole method can be extended to other building types, whatever. So it can be extended, so it will not be limited to only prefabricated building elements.
Okay. Thank you very much. Indeed, I think we need to now move on to the third presentation. Well done.
Thank you.
Good day, everyone. My name is Lynda Mbadugha. I am presenting a research paper on prospects for. Good day, everyone. My name is Lynda Mbadugha. I am presenting a research paper on prospects for. Good day, everyone. My name is Lynda Mbadugha. I am presenting a research paper on prospects for integrated design process in implementing construction waste prevention practices. Myself, Aghaegbuna Ozumba, and Winston Shakantu. The key outlines for this presentation are the introduction, research design, resource, discussions, and conclusion. In this presentation, construction waste prevention will be represented with CWP, and integrated design process will be represented with IDP. This slide describes the situation in the construction industry, highlighting that construction activities deplete our resources and generate waste. To manage the impact on the environment, traditional waste management measures were developed, which include the collection, treatment, and disposal of waste. Such measures react to the already existing condition and cater for already generated waste. Worthy of note is that once waste is generated, a negative impact on the environment may be unavoidable. This presents the need for sustainable construction towards waste handling. Recent developments on sustainability issues suggest the need for more sustainable and resource-efficient construction. Good day, everyone. My name is Lynda Mbadugha. I am presenting a research paper on prospects for integrated design process in implementing construction waste prevention practices, written by myself, Aghaegbuna Ozumba, and Winston Shakantu. The key outlines for this presentation are the introduction, research design, resource, discussions. Good day, everyone. My name is Lynda Mbadugha. I am presenting a research paper on prospects for integrated design process in implementing construction waste prevention practices, written by myself, Aghaegbuna Ozumba, and Winston Shakantu. The key outlines for this presentation are the introduction, research design, resource, discussions, and conclusion. In this presentation, construction waste prevention will be represented with CWP, and integrated design process will be represented with IDP. This slide describes the situation in the construction industry, highlighting that construction activities deplete our resources and generate waste. To manage the impact on the environment, traditional waste management measures were developed, which include the collection, treatment, and disposal of waste. Such measures react to the already existing condition and cater for already generated waste. Worthy of note is that once waste is generated, a negative impact on the environment may be unavoidable. This presents the need for sustainable construction towards waste handling. Recent developments on sustainability issues suggest the need for more sustainable and resource-efficient construction activities. However, some earlier studies highlight the need to improve production systems, and this often refers to CWP. CWP is a proactive initiative taken to prevent and eliminate the occurrence of waste in construction operations. Studies emphasize design as well as a more integrated framework as appropriate practices and approaches for implementing CWP. Studies have noted that the current design process is limited in meeting the requirements for efficient implementation of CWP due to its fragmented and sequential nature. Thus, IDP emerged as an alternative process and relies on integration without compromising flexibility in the design process. Although recent speculation suggests the possibility of implementing CWP using IDP, there is grayness in their application within the industry. Therefore, there is no articulation of the use of IDP for implementing CWP. This paper examines existing studies and frameworks on the prevention, reduction, and management of waste for a holistic understanding of CWP implementation through IDP. The objectives derived for this study are: 1. To identify CWP practices that call for IDP. 2. To identify the current practices, requirements, key principles, and values of IDP. 3. To describe the opportunities in using IDP to address the implementation of CWP practices. The research used a systematic review approach and employed a methodology that defined the research question, determined the required data, selected relevant academic databases, conducted a systematic literature search, defined criteria for inclusion, analyzed and synthesized data. The formulated question for this study is: what is the potential of IDP for achieving CWP in projects? Content analysis was used following processes as highlighted on this slide. The results follow a thematic representation. The themes used for this study are: Theme 1, CWP practices and the identified conditions requiring IDP. This theme noted that many studies focus on waste sorting, collection, and disposal. Only a few recent studies consider design measures for the reduction and minimization of waste. Theme 2, IDP and the identified characteristics. This theme noted different variations of IDP, which depend on the different perspectives and approaches peculiar to engineering, architecture, and the industry. Those variations still shared common practices and are evidence of flexibility inherent in the IDP framework. Under Theme 1, the subcategories considered on CWP include causes of construction waste, identified CWP practices, measures suggested on CWP, challenges of CWP implementation, drivers for CWP implementation. The details of these are contained in the research paper. Under theme 2, the subcategories considered on IDP include requirements for IDP, key principles of IDP, key values from the application of IDP, and identified challenges to implementation of IDP. The results reveal that most issues and practices for CWP focus on integrated practice in the construction work practices and highlight qualities that give rise to an iterative and integrated approach at the design stage. Therefore, there is the need for an IDP project for efficient implementation of CWP. Findings on IDP revealed some qualities that encourage integration, flexibility, and iterative process, which can be adapted to any field. Such qualities could be targeted at better waste management outcomes in projects, hence its use for the implementation of CWP. Results from this study show a pattern which emphasizes that the efficient implementation of CWP requires an integrated approach at the design stage. Such requirements appeared to align with the qualities of an IDP. In other words, IDP features have qualities that can be adapted to implement CWP. This makes IDP a more suitable design approach that will suffice as an ideal vehicle for integrating relevant practices that facilitate CWP. Here, the slide shows some of the requirements for efficient implementation of CWP and their association with some of the IDP features. CWP required a flexible method, stakeholder involvement and integration, iterative process, and so on. And all that can be found in the characteristics of an IDP. The benefits of bringing CWP practice into an IDP setting are to exploit the potential inherent in IDP to efficiently implement CWP practices. This would create an expanded and new framework for addressing waste generation. Since IDP is not generally practiced and not originally and currently waste-focused, some challenges include a lack of predefined integrated design systems and tools for adaptation and application of CWP. In conclusion, I would say that this study explored the relevance and need for IDP to achieve CWP and highlights the viability in the project design stage for CWP efforts. The key takeaways in this study are: 1. There is a need for an approach that rises above the hindrances of traditional work practices and approaches to facilitate the implementation of CWP measures at the design stage. 2. There is the possibility of adapting IDP to implement CWP and an opportunity for a systematic method that uses IDP as a vehicle for CWP in projects at the design stage. Further studies will be required along more detailed theoretical analysis and empirical studies to explore possible frameworks for adapting IDP to enable CWP while addressing any weaknesses and hindrances. Thank you.
Thank you, Lynda. Sorry about that. It seemed to get going, didn't it, eventually? And so that's great. So do we have, we've got 10 minutes now for questions. So questions for Lynda, please. Could I start then by just clarifying, really, when you talk about construction waste prevention, are you talking about the waste generated during the construction process, or are you talking more about end-of-life management of materials, which are being considered at the design stage?
About waste prevention, it's referring to actions you take before waste is generated. So those actions probably are implemented during design, so that the waste generation will be prevented.
So it's largely the waste generated during the assembly process of construction. That's the case, yes.
Yes, because when it's prevented at the early stage, the ones that appear during construction will no longer be there because they have already been taken care of.
Sure. And have you managed to come across any best practice yet in South Africa in terms of integrated design which brings in this waste management consideration?
Come again?
Have you managed to find any best practice examples in South Africa where construction waste prevention is being considered at design stage in an integrated process? Or is this just a wishful idea at the moment?
Actually, integrated design process has not been used to implement waste prevention. So, but there are speculations anyway, but it has not been tried out to see if actually it will work. So, but based on the suggested practices for waste prevention, every aspect of it points to the fact that there is a need for an integrated approach that will be applied during design. And when such is needed for efficient implementation of waste prevention, means there is need for that IDP.
Okay, that's fair enough. Yep, thank you very much. Thank you.
Just to follow on, my question is around this idea of combining these two concepts. Obviously, the IDP, as we always know, the whole point of IDP is to eliminate waste or make things better, bring people together. So I'm just wondering what additional you're adding to this, or are you just repackaging the agenda of IDP?
Okay, from extant literature, I have not come across where IDP was used particularly for waste. Rather, they can be used for high energy buildings, high performance buildings, but not as in formulated for waste prevention. So when you have an integrated approach at initial stage, there is a possibility that it can achieve some level of waste reduction. But when it is not typically focused on it, it doesn't really mean it's supposed to attain the level of performance expected of it when it's being applied, focused particularly on waste prevention. So in this aspect, being that it's supposed to achieve waste prevention, every aspect of it will be adapted in such a way that it will achieve optimum performance.
Okay. We have a question in the chat box from Aziz. What do you think the challenges are for this to happen in practice? So I'm guessing, what do you think the challenges are for this to happen in practice? Do you understand the question, or should I get Aziz involved?
Okay, the challenges.
Or do you want me to? Do you want me to get him on board to ask the question?
Okay, so that he can maybe rephrase it, so that I can get it better.
Aziz, I've given you a presenter's view. So can you probably address your question to Lynda? Aziz, are you there? Yeah, okay, he's coming up. Yeah.
Yeah, sorry. Okay. No, Lynda, you said, thanks for your presentation, by the way. It was really good. And I think the idea is great. You mentioned that at the moment, you haven't seen it being practiced, like you haven't seen people actually doing it. So I guess the idea that you're promoting here is to design out waste from the outset, from the start. So the question is really, what do you think the challenges are for this to actually happen in practice, to see it actually being done by practitioners to implement this integrated design process as a construction waste prevention method?
Okay, the challenges from what I've identified so far is that there are no methodologies on how to implement such practices for waste prevention. So if there are means to implement them, I believe that there's a possibility that the stakeholders can try those practices out. So probably there are none. So my research, it's an extension of it to design a framework for integrated design process, as in the methodology, so that it can be used, it can be implemented to achieve waste prevention. So I believe if such is in place, then I think the industry can try the processes out.
Right, thank you. That was really good. Thanks.
Thanks very much. Okay, I think we've come to the end of our time now. Thank you, Lynda, for answering those questions, and thank you very much to all the presenters that presented some really interesting papers, and thank you for the attendees as well, and for your questions. So we shall finish now, and if you go back to the foyer and see what's coming up next on the programme, we'll probably get another quarter of an hour break, I think, between now and the next session. Thank you, everybody. All the best.